Hey chemistry crew, Mr. Collier here, and today I want to show you a little bit of page 17 in your gases packet, which is combined gas law stuff. So there's a few things I want to point out. Mostly the answers are here and they're on Google Classroom, so not too much to say, but there's a few things I want to mention. So on question number 2, it says determine the volume at STP. So STP, standard temperature and pressure, is going to be 1 atmosphere and a temperature of 0 Celsius. However, our temperatures need to be in K, so that's 273 K is your standard temperature. And since this problem was already given to us in torr, we're going to make our standard pressure torr as well, and that's where that number 760 comes from. That would be from your reference packet, the standard 1 atmosphere, but in torr. Okay, so that's how you would do that. Moving down to number 2 here, what pressure, right? And so we're solving for P1 here. That's where that came from. And the equation, and I didn't mention this in the previous one, P1 V1 over T1 equals P2 V2 over T2. Plug in your numbers that you're given, cross multiply, substitute, solve. Pretty straightforward. Question number 4. What is the volume of a gas at standard temperature and pressure if it occupies 14.9 liters, 16.8 Celsius, 136 kPa? That's all this stuff over here, right? And then my standard temperature and pressure, 273 is that standard temp. And then now notice I used 101.325 as my standard pressure because, again, I'm trying to match the units that were given to me in the problem. They were kilopascals, so I report in kilopascals. One final problem, and that is number 5 here. We are given an initial volume, an initial temperature, and an initial pressure. That's these guys here, P1 V1 over T1. Then it says, what is the Celsius temperature? That's going to come into play at the end here. If the pressure of the gas is changed to 232 kilopascals and its volume is 1.1 liters. So 2 things going on. One, we started in milliliters, but we ended in liters. So I need to convert one of them. I chose in this example to convert my 1.1 liters into milliliters. So that's why that milliliters is there. I could have gone the other way. I could have made this milliliters over here, this 592. I could have made that liters. Either one would work. The other conversion I needed to make is I was given at the beginning atmospheres and at the end kilopascals. So I choose to take my kilopascals and convert them to atmospheres, which is where this number comes from. Again, I could have made them both kilopascals. I just chose to convert it this way. As long as the 2 things on both sides are the same, you're fine. Now I can solve for T2. This is definitely the most involved of these 4 problems. Cross multiply, simplify for T2. That's going to spit out this number 450, but remember that answer is in Kelvin. So now I need to subtract 273 to make it Celsius. Definitely a slightly more complicated question, but there you have it, very doable. Let me know if you have any questions on page 17.